We wanted to take this opportunity to talk about one of the investigations that's headed to the International Space Station. The next cargo craft that's headed to the orbital complex is planned to launch next week, and one of the experiments that will be on board is part of the experiment called CATS, or the Cloud Aerosol Transport System. This is going to use a LiDAR system pointed back down at the Earth to help create better models of the planet's climate feedback processes. So we have two gentlemen here this morning to join us to talk about this, Dr. Matthew McGill and co-investigator Dr. John Yorks, joining us from NASA's Goddard Space Flight Center in Greenbelt, Maryland. Good morning.
Good morning.
Good morning.
Thanks so much for joining us. Matt, can you tell me where the idea for this investigation came from?
Sure, Nicole, thanks. The Cloud Aerosol Transport System, or CATS, it's an instrument, a new Earth science instrument for the space station, designed to characterize the global distribution of clouds and tiny aerosol particles in the Earth's atmosphere. The instrument heritage for CATS is derived from our long-standing heritage in developing high-fidelity instruments for NASA's high-altitude aircraft, such as the ER-2. The science behind CATS derives from our need to demonstrate advanced measurement concepts that can be used on future free-flyer satellite missions.
Great, and can you describe the hardware flying on SpaceX 5 next week?
Sure. CATS, as you mentioned, it's a laser remote sensing instrument, or LiDAR, and LiDAR works a lot like radar, except we use low-energy pulses of laser light. The CATS instrument has two lasers, each with different characteristics, a receiving telescope, and special photon counting detectors. It's about the size of a household refrigerator you see in the animation there, and there's an awful lot of technology and capability packed into the box. Once on ISS, CATS will mount to the Japanese Experiment Module Exposed Facility, and it can operate there for up to 3 years.
John, would you explain how this LiDAR system measures particulates in the atmosphere?
CATS uses a laser that generates three wavelengths, or colors of light. Internal to the laser, special optical crystals are used to generate these wavelengths by taking the energy of two photons and adding them together to create a single new photon. The final output beam is made up of all three of these wavelengths, and these photons are then transmitted to the atmosphere in groups at the speed of light. As the photons encounter clouds and particles, scattering of the laser beam occurs. Very few of these photons are actually scattered back to the instrument's optical telescope, but the ones that are collected and counted by sensitive detectors and electronics. By timing the difference between the emission and detection of the photons emitted, we can determine the altitude of the particles in the Earth's atmosphere. Thus, CATS will measure the vertical distribution of the particles in the Earth's atmosphere.
Okay, and how does the presence of those particles impact the climate processes?
Well, small particles from desert dust, such as dust and also ash from volcanic plumes are known as aerosols. Aerosols, besides their harmful impact on human health, can also impact climate by directly scattering and absorbing solar radiation. They can also indirectly influence climate by interacting with clouds. Clouds are one of the largest uncertainties in climate prediction because they are a key regulator of the planet's average temperature. Water clouds near the surface tend to reflect sunlight back to space, cooling the Earth's surface, while high ice clouds tend to trap the Earth's radiation and warm the atmosphere. Changes in the abundance or location of these clouds and aerosols can have a big impact on climate, even more so than the effect of greenhouse gases. Computer models that forecast climate change will use CATS data to improve their forecasts and reduce the uncertainties in climate prediction.
Okay, does the orbital path of the space station matter in terms of the data you're going to gather?
The ISS orbit is a great match with the goals of the CATS instrument. The 51-degree inclination orbit provides comprehensive coverage of the tropics and mid-latitudes, and it also encompasses the majority of the Earth's population and land masses. In addition, the ISS passes over a different location at a different local time every time, and this permits studies of day-to-night changes in clouds and aerosols, which cannot be obtained from polar orbiting Earth science satellites.
Okay, very interesting. Matt, will CATS run continuously, and how is it commanded and controlled?
Sure. CATS is controlled from a very simple ground station here at Goddard using ISS-provided software. They have a software package called Trek. They provide that to the users. CATS is designed to operate autonomously, so once it's on and we're safe for operation, we can operate for extended periods of time. Now, because it's a laser, when astronauts are out and about, we do turn off the laser for safety concerns, and when there are docking vehicles, we'll turn off because the exhaust plumes from the vehicles can contaminate or damage our sensitive optics. Aside from that, we're intended to operate continuously or near continuously, sending data in near real time down to the ground where it's going to be continuously injected into these aerosol forecast models that John talked about.
Okay. I also know that CATS is part of the Earth Right Now campaign. Can you tell us how the CATS mission fits in with that effort?
Sure. CATS is really a cost-effective way to demonstrate new Earth science measurements and new technologies using the ISS as a low-cost, easy-access platform. Technologies in the CATS instrument, so for example the lasers or specific technologies that are in the detector-receiver chain, they're providing on-orbit demonstration and validation that the technologies and the measurement concept behind CATS are mature enough and ready to use in the more demanding, more expensive NASA free flyer missions in the future. We used what we call a build-to-cost approach to building CATS. We think that's a fiscally responsible way to approach these tech demo and risk reduction measurements for Earth science. And as space station matures now into an operational science platform, utilizing that capability for Earth science becomes an exciting new era for the Earth science community.
Great. Well, thank you both, gentlemen, for joining us. We really appreciate it. Again, Dr. Matthew McGill and Dr. John Yorks from the Goddard Space Flight Center. You can find out more about their research at www.nasa.gov/CATS.